Many are familiar with this website, the internet running on herokuapp.com. The website was created by Dave Hofner to present 43 controls which provide challenges to those learning to code Selenium scripts that automate manual actions real users perform on an internet browser such as Google Chrome. These tutorial websites include elementalselenium.com and seleniumguidebook.com. Selenium makes use of older WebDriver technology that controls browsers. But Google has added what it calls Puppeteer technology to both diagnose and control its browser, which is now much more complex than when WebDriver was created, including capture of precise timings of response time for each manual action. Puppeteer is used in Chrome's Lighthouse developer tools, which provides the precise diagnostics needed to script manual actions in TypeScript code instead of Selenium. TypeScript is a superset of the JavaScript programming language that is the default language controlling browsers. TypeScript is run to automate actions in the Chrome browser by the Flood Element program installed locally using a shell script. When the scripts are pushed through to a remote GitHub repository, others can git clone into their own machines to run. Both Element TypeScript and Selenium control a single user GUI at a time. But we also want to see what happens when many users on many browser instances run at the same time, exercising the website. We want to see how much a challenging JavaScript control can impact the server's environment memory, CPU, and other resources. But we don't want our experiments to overload Dave's public site for everyone else. So we run the app as a Docker container within the AWS or other cloud. The container and environment under test is built by invoking a build script that retrieves files from GitHub, which makes use of a Docker image housed in Docker Hub and uses it to instantiate an app server for testing. It uses credentials for an AWS account associated with the appropriate groups within appropriate permissions and roles needed. We use the Flood.io service in the cloud or on-premises to emulate those many users by running automation scripts pulled from a GitHub repository. Flood element scripts are a new innovation because it emulates actions within each user's browser. Historically, Java code used by JMeter or Scala code used by Gatlin emulate load by simply emulating just the exchange of what is sent between client browser and server. But a lot of work now occur inside the client browser. Multi-user flood runs are controlled by run parameters such as the number of virtual users being emulated. Run shell scripts can be used to manage various runs, test data, and results over various variations in run conditions. It's important to have a metrics dashboard that helps people make sense of measurements collected over time. This article talks about the use of New Relic. We have an instrumentation script which installs an agent to run alongside the app. Because the sample app under test was written in the Ruby language, the agent is installed as an RPM file specified in the gem file referenced during installation. During runs, the agent sends notifications about events to a process installed using a Docker image in Docker Hub from New Relic. The monitoring process transfers events collected by agents to a metrics dashboard at newrelic.com. To validate communications, a license key obtained manually from the New Relic website is installed when the agent is installed. The license key plus IP address and port number of the metrics collector are provided to Flood so that it can add its metrics to New Relic over time. These metrics include the number of users, transaction response times, the rate of transaction per second processed, network bandwidth throughput, and transaction pass-fail error rates. When we also add the cost of each run, we would be able to identify which configurations would provide the most profitable number of transactions per dollar.